Okay, so looking at question 4 of the examcraft mock. Question 4 tells us that you want to find two values of x for which a quadratic 3x squared minus 7x minus 7 is equal to 0. In the question, asks you to give the answers correct to two decimal places. This sentence, give your answers correct to two decimal places, is a trigger. It is meant to remind you that you're going to do your minus b formula. So the minus b formula is in the log tables for quadratics. In terms of the quadratic, the number and the sign in front of the x squared stands for a, the number and the sign in front of the x stands for b, and the number on its own and its sign stands for c. So in this case, a is 3, b is minus 7, and c is minus 7. You plug them into the formula. When you plug them into the formula, just plug them in. Don't tidy it up. Put them in using brackets. So you remember you've got a minus 7, okay, and you'll fix the sign for that one later. So when you tidy them up, you're getting a plus 7 plus or minus the square root of 49 plus 84. So this minus and this minus gave you the plus. Okay, and it's all over 6. Tidy it up, so your 49 and 84 gives you 133. Plug that into your calculator and you will get x being two values. X is either equal to 3.09 or x is equal to minus 0.76. Okay, so when you are giving those two final answers, make sure you round correctly to decimal places. So if they're asking us to round correct to two decimal places, you look at the third decimal place, and if it is a 5, 6, 7, 8, or 9, you add 1 to the number in front. Okay, part 2 of this question is to solve simultaneous equations. Alright, so in terms of these two simultaneous equations, the simultaneous equations are both linear equations. There is no x squareds or y squareds. Alright, they just involve x's and y's and numbers. So you're going to solve it by elimination. So what you do is you line up your two equations so things are above each other. So you've got currently x's over x's, but then you've got a plus and an equal sign over each other. So rearrange it so you go x's equals y's minus your numbers. X's equal y's plus or minus your numbers again. So when you arrange it like this, then you look at either your x's or your y's and decide you want to get rid of one of them. So in terms of this, I have a minus 7 and a plus 5. So if I multiply the top line, everything in it by 7, and I multiply the bottom line, everything in it by 5, I will end up with a plus 35y and a minus 35y. So that works. So I multiply them out. I get 28x equals 35y minus 147. 15x equals minus 35y minus 25. Right? Draw a line underneath and then treat it like three separate sums. So you've got plus 28 plus 15, so you add them and you get plus 43. Your equal sign stays an equal sign. These cancel, and then here we have minus 147 and minus 25, so we get minus 172. To get the x on its own, you're going to divide your minus 172 by your 43, and you get x equals minus 4. To get your y value, you plug your x back into either two of your original equations. So if we plug it back into the first, we're getting 4 times minus 4 equals 5y minus 21. So minus 16 is equal to 5y minus 21. So 5 is 5y, y is 1. And then at the last part of the question says verify your solutions. So verifying your solutions mean plug your answers back into the original, both originals, and see if they work. So if we plug them back into the first one, so instead of writing down x, you're writing down minus 4. Instead of writing down y, you're writing down 1. So we have 4 times minus 4 equals 5 times 1 minus 21. When you tidy that up, you get minus 16 equals minus 16, so it works. The other one, you got 3 times minus 4 plus 7 times 1 equals, if I move it over there, minus 5. So you get minus 12 plus 7, which gives you minus 5. So the right side equals the left side, so it's verified, so it's done. And that was question 4.